Hello again, fifth graders. Today we're going to go ahead and take a look at dividing fractions by whole numbers. So our last lesson, we learned how to divide whole numbers by fractions, but this time we're going to go ahead and flip-flop that order, and we're going to take fractions and split them up by whole numbers. So recall, when we're dividing by whole numbers, we are splitting up the dividends into the amount of equal groups as indicated by the divisor. So for instance, 10 divided by 5 equals 2. So we can think about this as taking 10 and splitting it up into 5 equal groups. So in this case, we can split up 10 into 5 equal groups. And if we did that, there would be 2 in each of those equal groups, which ends up being your quotient or your answer. Awesome. We're going to use the same train of thought when we're dividing fractions by whole numbers. And what we're going to do is we're going to take the fraction and we're going to split it up into the amount of groups as indicated by the divisor. So in this case, we're going to need to take 2/3. We're going to need to split up 2/3 into 4 equal groups. Your quotient or answer will be the size of each of the equal pieces that you've created, and it's always compared to the whole. So we need to start with 2/3. Let's go ahead and model this so we can get an idea of what we're talking about here. So we're going to be starting with 2/3. So I'm going to go ahead and highlight my 2/3 because that's what I'm focusing on. I need to take this portion right here and I need to split that up into 4 equal pieces. So really it's already cut up into 2 equal pieces. I just really need to make 2 more cuts to create 4 equal pieces. So I'm going to cut here and here, and this was already cut here. So I have just created 4 equal pieces, 1, 2, 3, 4. So I've literally just split up 2/3 into 4 equal groups. So we split 2/3 into 4 groups. Now the question is, what is the size of each of these groups? Now remember, when we are talking about fractions, we always compare it to the whole thing. So we've actually just created 1, 2, 3, 4, 5, 6 equal pieces. This is now 1/6. So your answer is 1/6. 2/3 divided by 4 is 1/6. Let's take a look at another example. 3/5 divided by 6. We need to break up 3/5 into 6 equal parts. Okay, so let's go ahead and highlight 3/5. So I have 5 equal groups, that's fifths. I'm going to take 3 of them. Okay, terrific. So that's what I'm focusing on right there. I need to create 6 equal parts within this highlighted space because that's my 3/5. I need to create 6 equal parts. Well, I already have 1, 2, 3 equal parts. So really all I need to do is cut these in half. Because if I cut them in half, I now have created 1, 2, 3, 4, 5, 6 equal groups, just like I needed to. But now the question is, what is the size of each of those pieces? Well, let's see. Let's do that to all of these. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. So we have just created tenths. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. So what is the size of each of the pieces that we just created inside of here? We created tenths. And that is the answer to the division problem. Now again, as we're learning, while we love models and it really helps things make more sense, having a visual, we don't always have the time to draw pictures. So there is a shortcut, and it is the same shortcut that we used when we were dividing whole numbers by fractions. We can divide fractions by whole numbers by using keep, change, flip. Now remember, we can turn any division problem into a multiplication problem. Now again, if you change your operation, you're going to need to change something else about it. So when we're dividing by fractions, we need to multiply by the reciprocal. well, not even by fractions, by any number. And in fact, we're going to be dividing by a whole number. So really, it's just that we need to flip whatever that second number is. We need to flip the divisor. So again, we have keep, change, flip is our little saying to help us remember what we need to do. KCF is what we're going to say for short. We keep the dividends the same. So we keep that first number the same. We change the operation from division to multiplication. We flip the divisor to its reciprocal. Okay, then you multiply just like you normally would. Remember to clear the skies before multiplying straight across. So let's go ahead and take a look here. This is the problem we solved on the front. 2/3 divided by 4, and we got 1/6. So let's go ahead and see if we use KCF, if we keep, change, flip. Let's see if we do indeed get 1/6. So 2/3 I'm going to leave the same. You keep that the same. We change division to multiplication. And I need to flip my divisor, which 4 is the same thing as 4/1. So when I take the reciprocal, it's 1/4. You need to flip that fraction. We multiply straight across and we get 2/12. 2/12 can be simplified. We can divide them both by 2. And we get 1/6, just like we had modeled on the front. Okay, this answer, we got 1/10 when we split up 3/5 into 6 equal groups. Let's see if we get that with our new shortcut here. So this is going to be 3/5 times, now the reciprocal of 6 is going to be 1/6. So I'm going to flip my 6 and it becomes 1/6. We multiply straight across. We get 3/30. I can simplify this. And I do get the 1/10 just like we had gotten on the front. So this is proof that the keep, change, flip, that multiplying by the reciprocal does indeed work. So let's go ahead and do a few more examples. So this is going to be 3/4 times 1/2 because you flip that whole number, which was originally over 1. I'll kind of throw all of these whole numbers over 1. Multiply straight across and we get 3/8 and we're done. We're going to keep, change, flip. That's going to be 2/5 times 1/8. Multiply straight across. I'm going to go ahead and actually simplify before I multiply, and I get 1/20. Keep, change, flip. 5/6 times 1/3. Multiply straight across. We get 5/18. Can't simplify, so we're done. Keep, change, flip. 3/7 times 1/9. Multiply straight across. Let's simplify before we multiply to make life a little easier. 1/21, and we're done.